Hello and welcome to this session. In this session, we are going to discuss the following question, and the question says that find a polynomial that passes through the points whose coordinates are -1, 6, 1, 2 and 2, 3. We have to find a polynomial that passes through the points whose coordinates are -1, 6, 1, 2 and 2, 3. Since there are 3 points, so we will consider a polynomial of degree 2. Let p of x be equal to a plus bx plus cx square. Note that if 4 points were there, then we would have considered a polynomial of degree 3 and so on. That is, for n plus 1 points, we consider a polynomial of degree n. Now we put -1, 6 in p of x. We get 6 is equal to a minus b plus c. Then we put 1, 2 in p of x and we will get 2 is equal to a plus b plus c. And lastly, we put 2, 3 in p of x and we get 3 is equal to a plus 2b plus 4c. So we get the following system of equations. A minus b plus c is equal to 6. A plus b plus c is equal to 2 and a plus 2b plus 4c is equal to 3. Now we find the values of unknowns. A, b and c. After finding these values, we will put them in p of x and will get the required polynomial. So to find these unknowns, we use Gaussian elimination method. First we write its augmented matrix. The first 3 columns are of coefficient matrix and the last column is of constant matrix. That is 1, -1, 1 and 6. Second row is 1, 1, 1 and 2. Third row is 1, 2, 4 and 3. Now we reduce it into row echelon form. Using elementary row operations. For this, we have to make all entries below the first non-zero entry in that column 0 and the leading entry should be 1. We start with the first row. Here, the leading entry is already 1. Now we have to make all entries below 1 in the first column 0. In the second row, we have 1 below 1 we have to make it 0. For this, we subtract row 1 from row 2. The operation is R2 goes to R2 minus R1. Also in the third row, we have 1 in column 1. We have to make it 0. For this, we subtract row 1 from row 3. So the operation is R3 goes to R3 minus R1. And the matrix obtained is 1, minus 1, 1 and 6 are the first row entries, 0, 2, 0 and minus 4 are the second row entries, 0, 3, 3 and minus 3 are the last row entries. Now we come to row 2. In row 2, 2 is common in all entries, so we multiply row 2 by 1 by 2 to make the leading entry 1. So, we take row 2 as 1 by 2 row 2. Similarly, in row 3, we have 3 common in all entries. So, we multiply row 3 by 1 by 3. That means row 3 becomes 1 by 3 row 3. And hence the matrix obtained is 1, minus 1, 1, 6 in the first row, 0, 1, 0, minus 2 in the second row, 0, 1, 1, minus 1 in the third row. Now we have to make 0 below the leading entry of row 2. For this we subtract row 2 from row 3. The matrix now becomes 1, minus 1, 1, 6 in the first row, 0, 1, 0, minus 2 in the second row and 0, 0, 1, 1 in the third row. This matrix is now in echelon form. Now we write its equivalent system of equations. For this reduced augmented matrix, we have A minus B plus C equal to 6, B is equal to minus 2 and C is equal to 1. Now we solve the system of equations using back substitution. We have C is equal to 1 and B is equal to minus 2. We put these values in A minus B plus C equal to 6 and we get A minus 2 plus 1 equal to 6, which implies A plus 2 plus 1 is equal to 6, which implies A is equal to 6 minus 3, which is equal to 3. We get A equal to 3, B equal to minus 2 and C equal to 1. We put these values in P of x equal to A plus bx plus cx square and we get P of x equal to 3 plus minus 2 into x plus 1 into x square. This implies P of x is equal to 3 minus 2x plus x square, or P of x is equal to x square minus 2x plus 3. This is the required polynomial. This completes our session. Hope you enjoyed this session.